begin a new series of talks. The topics will be a bit different. We try to group the presentations around the same kind of topic together so that we can give some themes to the different sections. In this case, we are opening this series with a presentation by Boris Rozinov. Boris is a long-time contributor to Janus. He contributed some code to our project as well. He also flew a lot to come here. He's flying here from Toronto, and he's going to talk about a very peculiar approach, so something that will be very different from the talks that we've seen so far. And most importantly, it will involve Haskell that I know zero about, so I'm really excited to learn something new today. Thanks.
Thank you. Okay. Yeah. Okay. Hello, guys. Nice to see you all here, and thanks to Janus that unite all of us, and it's great product. And sorry. Okay. So a few words about myself. I started my career in telecommunication software development more than 20 years ago, and I was part of the team that developed directory assistance service for one of the major telecommunication providers. It was in Israel back then. Then I switched many companies, startups and bigger companies, use telephony boards. Probably my way is familiar to many of you who is like older, like myself. So I use dialogic audio codes, gateways, and media servers. I use Pika boards, company from Ottawa, and Redis's media gateways. I use Asterisk and SER. I develop products using different SIP stack, both commercial and open sources, and develop different kind of products, IVRs, application generator, PC-based PBX back then, different SIP server, contact center solution, and so on. Eventually, as most of us, I came to WebRTC and Janus, and during all my career, I mostly used mainstream programming languages. Originally, it was mostly C++, C, C++, Java, C#, and when I didn't have a choice, I also used JavaScript. Probably we all observe in our industry in software development, who deal with software development, trend towards more using functional programming approach. It makes its way to pretty much all mainstream programming languages, even including Java. And to understand better SP, I learned at some point several years ago, I learned Haskell, and to prove, also to learn it better, and also to prove for myself that it's really applicable to our domain, to develop an application for real-time communication. I use it to develop a few projects. Mostly it was on prototype level, but it was kind of fully functional for both Janus and Asterisk, and it worked pretty well. And I would like to share some of my experience with you. If I may ask you to raise hand if you heard anything about Haskell before. Okay. And could you raise your hand again if you really made some actual development with Haskell? Okay. Oh, one person hesitating. So it's a good audience. I have this privilege to be maybe the first person, to be the first who introduce Haskell to such a wide audience. And for my opinion, it's really, Haskell has great potential in our domain. Just few words about history of Haskell. It's a pure functional statically typed programming language. I will unload this term a bit later. And actually, it was one of the few languages which was created by, or maybe the only language which survived, which was created by a committee of computer scientists with purpose to have some common ground to exchange ideas. And it survived. Like many languages like that, they died pretty quickly when we have big committee working on something, but this one eventually survived. A few words about functional programming, I mean, and because this definition is very informal and incomplete, but the idea that we build program as composition of function. And we widely use so-called highly ordered functions, which basically something that's passing function as parameter to other function, which we're all familiar with when we pass callback to function. Yeah, it's also one of the cases, but also when we return get function back as return value. And basically, if we look at newer programming languages like Scala or Kotlin, we see that all of them also use kind of expression-oriented approach when all language construct, even like if and case, switch, they all return value. So basically, we just pass value from one expression to another. NFP also encourages mutability and purity. Now, what about Haskell adoption, if it's kind of language for academics? So they had, Haskell founder had this motto, avoid success at all costs, like, which means it was kind of joke, but the idea was that we don't make any compromises to gain wider adoption. We want to be honest to our principle, but despite all the efforts, actually Haskell reached sizable level of industry adoption, and it's used by actually big companies such as Facebook, GitHub, a lot of financial companies, and a lot of startups. Particularly, Haskell got a boost with cryptocurrency stuff, and I think, as I mentioned, Haskell has great potential also in our domain. We see that in like ranking of programming languages, Haskell nowadays is pretty high in the ranking. It's still far behind mainstream languages like Java or C#, but it's getting there. Okay, I briefly highlight of the language features, which by itself you probably can find this feature, some of these features in other languages as well, but I think this combination of features is pretty unique. So one of them is, and it's probably the most important one, is expressive static system, where we can achieve some compile time guarantees of our program just by explaining our model in terms of types. And it's also very lightweight. Green threads, like in Go or Erlang, threads of the language are not mapped to thread of operation system. So it's okay to, for example, to spawn new threads as much as we want. It's okay to wait or block inside thread. And also it's coming with a high-level async library. It has very powerful REPL, like interpreter, where we can just try and experiment in command line. It's cross-platform, so of course you can use it in any operation system and then deploy on Linux. It has a garbage collection optimized for functional programming. It has software transaction memory, when basically you can, as I mentioned, Haskell is pure, so it doesn't allow mutation of variables, so it's considered to be effect in Haskell terminology. But if you still need mutation, then we use this STM notion when we can make several mutation atomic. And it also has a high quality ecosystem with a lot of high quality packages. and very good community. Now, let's jump straight to the code, and I can promise you that if you know a bit about Janus, and I guess most of you know pretty well, um, I developed, based on projects that I did for Janus, I developed uh, Haskell binding of Janus protocol. I published it on GitHub. You can look at it later. And as samples application for this library, I created uh, just some simple apps which check interop between different Haskell Janus plugins. And I just jump straight to the code just to show you how it's. Can you see it, or should I make it larger? Yeah. Okay. So basically, this is a piece it's a function which get as parameter address of Janus, uh, registration parameters. It basically the purpose of this application is just to get incoming call on video call plugin and route it to C plugin, right? So so first we get handle to we create connection to Janus. We create queue where we're actually going to accumulate all messages that coming from both plugins. We create instances we attach to both to C plugin and to video plugin. Here you can see that basically we account for the case of failure. This may be type, if you're familiar with Java, is like optional. In case we have failure, we will go straight down to the failure case. If we were successfully able to attach to both plugin, then we send both requests, one on C plugin, another one on video call plugin. So we create both users. And when we please note when we created attached to plugin, we pass callback function with queue and type of the party, C party and video party. And then we start new thread where both messages for both plugins will be handled. This is this callback function, and this is actually main loop of the application. So we start infinite loop. We read messages from our message queue, and here important part which you will see in every Haskell program, which called pattern matching. Basically, we make case on different type of messages that that we are going to receive. So we can receive message from video side, we can receive message from SIP side, and basically when we receive offer on video side, we initiate call on SIP side, on SIP plugin. Once we got answer on SIP side, we pass this answer to video plugin. We, when WebRTC got media pass got established, we just log it. And when we get hang up event on one of the plugins, we forward this hang up to other party. So as you probably can see, It's pretty straightforward, and even if you don't know much of Haskell, it's still something that easy to develop. And uh, yeah. So basically, one of the approaches that Haskell promotes is type-driven development. The basic idea is that you define as a type um, as union type when it has different, for example, as we saw, different type of events or different situation in our application state. We defined types for both of them, and then we conveniently write function which handle these messages and modify our model. So it's pretty much standard approach, and the advantage that you get out of Haskell here is this uh, ability to describe precisely your data model as union type and then conveniently handle it, knowing that you don't miss any case. Haskell developers sometimes joking that because you can describe so precisely your models that if it compiles, then it's correct. And in many cases, it's not very far from the truth. But uh, in our case, when we have so complicated state machine and different states and different protocols and so many race conditions, we still can make mistakes which compiler will not catch, right? Compiler will happily compile our program and program is incorrect. For example, we can just invoke a sequence of operation which doesn't make sense. So we try to answer call which is already disconnected. Uh, so traditional solution for this approach is, okay, we just do testing. There's no much can we do. And the idea that I started to explore, can we actually describe our, to leverage power of Haskell compiler and rich type system to catch this type of errors in compile time. So basically, so we can get really close to this if program compile, then it works. And the approach that I took, which is not extremely unique, there are different implementation of this approach, but I had some innovation in this area, is basically to describe different types as different data types. So we have notion of basically program manage resources. We have different type of resources like calls, WebRTC session, and so on. And during its lifetime, a resource goes through variety state transition. For each state, only particular set of operation is allowed. And probably I just, it's just model, some simplified model of call state transition. And I will show you some simple program which is it's very similar program to one we saw before, but this one is written with this approach. And the idea here is that if you make any mistake in, for example, you try to answer a call which is not in offered state, you will just get compile error. So in this case, as we start with no resources. Basically, in the system, in order to be executable, your program should always start with no resources. And end with no resources. So basically all resources eventually should be released. So we start with creating new resource, which is call 1, which will be incoming call. Then we start a loop, and we move to state when call 1 is offered, which means we got incoming call. Then we start the block like try catch, but if call 1 got disconnected, so it's not alive anymore, we will break out of this block. So we guaranteed that inside this block, call 1 will be always alive. Now we start second call. We create resource for second call called call 2, and we invoke my call operation passing SDP offer that we got from the first call. Now we start another try block with call 2 with condition that call 2 is alive. Now we wait for the answer on second call, retrieve SDP answer, invoke invoke answer call with SDP received on the first call, and skip to the situation when both call is connected. So why it seems very simple program? The idea here is that you just cannot get it wrong. If you try to, for example, invoke answer call when call is already dropped, you will get compile error. So it gets us really close to the situation when it compile, then it works. This example, I won't go through this example in such a great details, but it's more probably realistic and complicated example. And in addition to the logic that we discussed before, it also has timer, monitoring of timer. So one timer is for the time when we got answer, so we can limit this time, and also we limit time of call duration once call got connected. So again, once we got it compiled, we know that it works. So we save time on testing, but most importantly, we also time if we need to make any change. Again, we got this compile time guarantees. So what is status of this framework? By the way, this framework is pretty generic. I do have binding for both Janus client API and also for asterisk ARI protocol. Both of them works pretty well. Main challenge that I have right now is slow compilation, because our compiled program basically incorporates proof of its correctness, which I anticipate it could be addressed by both improving of encoding, and Haskell compiler is improving very quick improvement. Yeah, it's pretty much what I had. I skipped a few slides, but if somebody has more questions or some want to discuss more about Haskell and how it could be applied to Janus and WebRTC and telecom in general, yeah, you are welcome to approach me. I will be here for next 2 days. Yeah.
Thanks, Boris. Thank you. Are there any questions for Boris? Okay, I see a couple there.
Hello. Thank you very much for this presentation. It's very interesting to see some functional language fonts So I have a questions. I have a question. One question: how Haskell does it treat hot reload aspect, as we could see in Erlang and Elixir language? That is very crucial for communication applications. Thank you.
Excuse me, could you repeat handles?
So, do we have something in Haskell language that could help us to have a hot reload mechanism? So, hot reload, it means that you could update your code without restarting the application.
Yeah, so I believe that at the moment there are no out-of-the-box solution for hot reload. So I know there are some efforts in this area, and I anticipate it will come at some point. Today, I guess the approach is just to apply some kind of microservices architecture when you break down your monolith or your application logic to pieces, and then you can uh, reinstantiate your services as you go.
Any other questions for Boris? Okay, then let's give Boris a big round of applause. Thank you.